Hello everyone, I welcome you all to this class. This is mathematics class. In our previous video, we studied the argument of a complex number. So today we want to get the polar form of a complex number. That is, given any complex number, we can express that complex number in polar form. Now let z be a complex number z equals x plus iy, where z is the complex number is not 0. Now the polar form of this complex number z is given by z equals modulus of z into cosine argument of z plus I sine into cosine principal argument of z plus I sine principal argument of z, and this is equal to modulus of z cosine theta plus I sine theta. This is equal to r cos theta, r into cos theta plus I sine theta. Now why I wrote this is for you to know that this theta we'll be using here. I would have just gone straight and write this, but it's for you to know that this theta we are using here is the principal argument. The principal argument is this theta. That's why I wrote this in first. Now I use r here to shorten it so that I replace the modulus of z with r. So r is same as modulus of z. Then remember our complex number is x plus iy. Now this x is in polar form. X is r cos theta. Then y is r sin theta. That's if you now do x, which is r cos theta plus I, and y is what? R sin theta. So if you factor out r is common. We will now have r cos theta plus I sin theta. So this gave us the polar form of any complex number. So with this, we can find the polar form of some complex numbers. We already know how to get the principal argument of any complex number. Looking at this question, they say express square root of 3 minus I in polar form. So we want to express this complex number in polar form. Solution. Now let's find first of all the argument. Principal argument. Let's find the principal argument of this complex number. In our previous video, I told you that if the real part is positive, that's the one that does not go with I. If the real part is positive, the principal argument is simply tan inverse of y divided by x. That is tan inverse of y is the imaginary part. What's the imaginary part? Is the coefficient of I. What's the coefficient of I here? Minus 1 divided by x is what? X is the real part. What's the real part here? Square root of 3. So what do? We can bring this minus out, right? This will minus tan inverse of 1 over root 3. But tan inverse of 1 over root 3 is what? 30 degrees. Now our angles, the principal argument must be expressed in what? Radian. So we'll convert this to radian. Just multiply it by pi divided by 180 degrees. So if you do that, 0 cancels 0. 3 divide itself 1. 3 divide 180, you have 6. So now we will now get what? Pi over what? 6. So pi over 6 is equivalent to what? 30 degrees. So pi over 6 in radian is equivalent to 30 degrees. So remember, we have negative here first, right? That's negative. This one gave us what? Pi over 6. So negative pi over 6 is what? The principal argument of this very complex number. So quickly, we now write the formula for the polar form of complex number. That is a polar form of complex number. Z is equal to modulus of z into cosine theta plus I sine theta. So from this formula we wrote, what is remaining? Can you guess what is remaining? Yeah, we need to find what the modulus of what? Z. Modulus of z will be equal to what? Now, if a modulus of any complex number z equals x plus iy, then modulus of this complex number is given by this, is equal to the square root of the real part squared plus the imaginary part squared. So this is the formula for finding the modulus of any complex number. So we are going to use this to find the modulus of this complex number. That's square root of, what's the real part? Square root of 3. That's real part, the formula says real part squared. That's square root of 3 squared plus the imaginary part squared. What's the imaginary part? Coefficient of I. That's -1 squared. So this will be square root of square root of 3 squared will be the square root will cancel the square, have 3 plus negative I squared will give you, sorry, -1 squared will give you what? +1. So you have 3 plus 1 will give you what? 4. So we have 4 here. So we'll be having square root of 4. What's the square root of 4? 2. So quickly, we write our formula again. Z will be equal to modulus of z into cosine theta plus I sine theta, and this will be equal to, what's the modulus of, what do you get as the modulus of z? We got the modulus of z to be what? 2. So 2 into what? 2 into cosine what? Cosine, what's our theta? The principal argument, which is what? Negative pi divided by 6 plus I sine negative pi divided by what? 6. So quickly, we can finish up the writing here. So this will be equal to 2 into cosine of negative angles is same thing as cosine of the positive angle, because cosine is an even function. So cosine negative pi over 6 is same thing as cosine pi over 6. So we have cosine pi over 6 plus, but sine of negative angle is negative sine of the angle. So I'll bring this negative, this minus out. I'll bring the minus out. So I'll be having, if I bring the minus out, I'll having minus I sine pi over 6. So this gave us the required answer we are looking for. This gave us the required answer we are looking for. So what we got here is what? We got 2 into cosine pi over 6 minus I sine pi over 6. Let me just write it very well. So with this, we have expressed this complex number in what? Polar form. So can we just express another complex number in polar form? Okay, simply we can do that. Let's just modify this one. What if I decide to put this, let me put here -1. Let me put here -1 and put here negative. So negative. So we want to express this complex number, -1, -I in polar form. Solution. So what do? First of all, get your what? Principal argument, arg z. Then I told you in our last video, that's when we were finding the principal argument of complex numbers, that if the real part is negative and the imaginary part is negative, then the formula you are going to use to get the principal argument is tan inverse of y over x minus pi. So this is the formula you are going to use if the real part is negative and the imaginary part is negative. That this will be tan inverse of, what is your y? Your y is what? The coefficient of I. Coefficient of I is -1. What is your x? The real part, which is -1. Then minus pi. So this will be tan inverse of -1 divided -1 will give you 1 minus pi. What is tan inverse of 1? Tan inverse of 1 is what? 45 degrees. So you can convert the 45 degrees to radian, right? Because our angle must be in radian. Convert to radian by multiplying it by pi over 180 degrees. So 5 divide 45, I get 9. 5 divide 180, I get 36. 9 divide itself 1. 9 divide 36, I'll get 4. So my answer is what? Pi over 4 in radian. So I got pi over 4. I got pi over 4. Then minus what? Pi, right? So this will be equal to, what's the LCM? 4. Right? 4 divided 4, 1 times pi. Then minus, here is 1, right? Because pi is just as pi over 1. So 1 divide 4, 4 times pi. I have what? 4 pi. So this will be pi minus 4 pi will give you 3. Give you 3 pi, then over 4. Okay, -3 pi over 4. So this is what we got as the principal argument. So can we get the modulus of z? So let's get the modulus of z. Modulus of z is equal to square root of the real part squared. The real part is -1 squared plus the imaginary part squared, coefficient of I squared. So this will be -1 squared is 1, -1 squared is 1. So 1 plus 1, 2. So that's square root of 2 is the modulus. So there are complex numbers z. Z is equal to modulus of z into cosine theta plus I sine theta. And this will be equal to modulus of z gave us what? Square root of 2 into cosine. What is our theta? The principal argument. -3 pi over 4 plus I sine -3 pi over 4. But I told you in our previous solving that cosine of negative angle is same as cosine of the positive. So cosine -3 pi over 4 is same as cosine 3 pi over 4. Then sine negative angle is negative sine of the angle. So we bring out this minus here. When we bring out this minus, it will change this plus to what? Negative. So we have negative I sine 3 pi over 4. So this gave us the required answer to this question. So thank you for being part of this video. In our next video, we'll be solving more examples on this topic. Thank you.